Okay, so from my video yesterday regarding running Windows 10 on a Raspberry Pi 4 from an SSD, here's the setup procedure. So you need to go to the WOR project website and click on Downloads. And there's a new release again, so there's alpha.2 now. And if we have a look at the changelog, there's nothing really that would change too much with this installation. So let's click on that and then just download it somewhere. So I'm going to download mine to the desktop. Then what you need to do is create a new folder. I'm going to call mine WOR 200 Alpha 2, and then just unzip that into the new folder. So Control A, drag it into the new one. This is the bit that writes the image and gets all the extras that you need to the card. You need to download separately the version of Windows. Now I'm going to use this one, which I've already used in a video. I've tried both of these work. So for this video I'm going to use this 18362.267. So I've already downloaded that onto an external drive because this is my 2010 Mac and there's not a lot of storage space on this. Okay, so you can see there's a exe file at the bottom, wor.exe. Double click that and it will launch the writer. So you can say here, run anyway, and plug your SSD drive into your Windows computer. This is a Mac running Windows 10. So select your language, hit next, select the Raspberry Pi 4 setting, and on your device you need to select your SSD. You can see here, this is my 120 gig SSD, which is in a USB caddy. So it enables me to plug it into the computer. So click on that and you can see it says it's enough space. Hit next. So select the image you're going to use, and in my case it's on an external drive. So if I go to Seagate and go down to the bottom here, Windows 10, so one of these, 18362. So I'll double click on that, click on the image and hit open. So that's basically Windows that it's putting there. Windows Edition, so you see it's come up. Hit next. Use the latest package available on the server, so that will download any package it needs. Hit accept, accept again, and next. Use the latest firmware available on the server. You can see it's picked Raspberry Pi 4 here. Hit next. And you don't need to change any of this for how we're doing it. So hit next and it will write the image to the SSD. So when it's all finished, you'll have a boot, which is this one here. And you'll have a Windows drive, which is this one here. And that's it. Eject your SSD. You can plug the SSD into your Pi with the USB adapter, but it's not going to work just like that because the Pi won't boot from USB. What you need is an SD card with the necessary files on it to mean that it will boot from the SD card but then straight away go over to the SSD. So that's what you need this next bit for. So if you follow the link in the description, so this is Raspberry Pi 4 UEFI firmware. Now there's a newer version, I haven't tried this one yet, but version 1.11. It keeps getting updated, so you always download the latest version. So let's download that to the desktop. And save. Won't take very long because it's very small. And then all of the files in here need to be unzipped and written straight to the card. So again, you can do Control A and then you can drag it to the root of your card. So if I let go there, that's going to copy that over. So now if I close that down, open up my card, you'll see all the necessary files on there. The config.txt, I don't think you need to do anything with this because the overclocking, if you wish to overclock, it won't be overclocked I think by default, but the overclocking is done on the Pi. So let's close all that down and put this SD card into the Pi, and that's going to be the SD card that it boots from. and then the SSD is going to run Windows as the operating system, because that's going to make it a whole lot faster. Okay, so this is what you're going to need to have plugged into your Pi. So here's my Pi. I've got an HDMI cable plugged into the monitor. This is a very important bit. This is a USB-C on-the-go adapter. The reason you need this, because at the moment the Ethernet and the USB sockets don't work. So if you want USB and you want internet, then the only way to do it is to have this on-the-go adapter. So we have our official Raspberry Pi power going into the on-the-go. That powers this adapter and any devices plugged into it, but it also powers the Pi. And then we've got a USB cable going to our SSD drive. So Windows is running from here. The little SD card is in there, which is running the boot. It only does the very initial boot, that's it. And then the little tiny dongle here is for my mouse and keyboard. Let's boot up the Pi. Okay, so it's booting up now. If everything's done correctly, you should see this screen. Let it go through it. I always let it, before I overclock or mess about with any settings, I let it normally boot and run and set up Windows first of all. Now this bit is a whole lot quicker since we're using an SSD. With the SD card, it was such a long process. Okay, so you can see the normal language part. So obviously put in whichever version of Windows you want and let it carry on. I won't really explain how to do this bit because this is just like a clean installation of Windows. So we'll come back when Windows is fully booted. Okay, and here we have the Windows desktop. Actually, that didn't take that long at all, really. That was quite impressive. Right, before we add the internet to it, go into settings. There's a few things that are worth changing for the Pi because it's all experimental and it's, you know, early stages. Just to get it to run a bit quicker on this quite basic hardware. Updates. A new feature which got added to Windows is that you can pause updates. So if I pause it, and then I go to advanced options, I can actually pause it for quite some time because we don't really want it to do anything at this stage. Obviously, if you're intending to run Windows on the Pi as one of your main operating systems, you need to register it, and also I would leave updates on because that keeps it more secure. But here we're going to go for so 10th of June, so it's not going to try and apply any updates until 10th of June. I also press Ctrl-Alt-Delete and go into Task Manager, click on More Details and Startup. And in this case, I'm going to disable OneDrive. Although it's a useful feature, again, it takes resources, and security notifications I'm going to disable just so there's less running. Again, this is just for me, just to speed it all up. I'm not really going to be browsing the web much on this. And close that down. Next step is to turn off visual effects, and we'll do that by pressing Windows R, typing in sysdm.cpl and hit OK. Then we need to click on Advanced. See under Performance where it says Settings. It defaults to this, let Windows choose what's best for my computer, but you can see that everything's left on and we could do with better performance. So adjust for best performance. Everything gets unticked. Things like fades and transparencies and things like that disappear, so it makes the whole operating system just perform a bit more snappy on low-end hardware. So click OK. Right, so we're pretty much done on that, but we also need to check what clock speed we're running at. So let's go Control-Alt-Delete, Task Manager, click on Performance, and you can see that at the moment we're at 1.5 gigahertz. So what we're going to do with that is we're going to boot up and press Escape on boot. So let's close this down. We can do a restart here. So when you get this screen, press Escape. Go down to Device Manager, Raspberry Pi Configuration. You don't need to overclock. I'm going to hit Custom and do 2147, which on stock firmware is as high as you can go. I've got a Pimoroni fan shim, so that will keep it cool. Press F10 to save, and yes to confirm, and then Escape to exit. Keep pressing Escape and go to Continue and press Enter. Okay, so let it reboot back in. You want to shut down, you want to take the SD card out of the Pi and also unplug the SSD because you're going to need to change something on a computer. Okay, so now you need to plug your SSD into something like Linux or Ubuntu, so you can use Raspbian or various different systems. I'm going to do it on my Mac, which I was using with Windows before, but now it's using Mac OS just because it's easy for me to screen record on. And you can see two folders come up. The boot one is the one we're interested in. So we open that up and we've got config.txt. So now we need to put all the overclocking in here. I'm just going to have a look through and see if there's anything in here. Yeah, so disable overscan has been added, which is good, which is the one that gets rid of the black bars around the operating system. I thought that was the case. So I can delete disable overscan. Now the operating system ran at 1080 anyway, so I don't need my HDMI ignore either. You don't need a space in this, but I like to put a space in. So over voltage equals 6, ARM frequency 2147, GPU frequency 750. And this last bit I'm going to not use. That was something I used in another video. So these are the three elements you need to add to it. File and save. Okay, so we also need to do the same to the SD card. So pop the SD card into your Pi or your MacBook. This also works with Windows, by the way, as well, but I think the ordinary notepad doesn't work, so you have to use something else. So open up the SD card that it boots from, go to config.txt, and you'll see all the same sort of stuff in there. So I'll put in just the 3 lines that I put in on the SSD. You might not need to do this on both, but I do it on both and it works for me. So let's hit save and then pop both of those into the Pi. So plug the SSD in through the on-the-go adapter and put the SD card in the Pi as normal. Okay, so let's just check the clock speed before we do the next step. So go to Control-Alt-Delete, hit Task Manager, Performance, and you can see we're running at 2.15 and the CPU is currently 37%. So if we click on Windows, and we can scroll up and down, maybe make the peak go up a little bit, but you can see it's coping particularly well now. So we can click on Windows and we can move up and down, and maybe we can try and launch something and see if that peak goes up. You can see that it did. Let's just snap it either side. There you go. So 45, 30%. Obviously always getting close to the level of RAM there. Right, so next step. Okay, so now that we've done the initial boot of Windows and we know that everything is up and running, we can introduce another cable, which is this one. This is a USB hub, but it also has Ethernet. So I can give an internet connection to the Pi because, as we said before, the Ethernet on the Pi doesn't work at the moment. Obviously things will change in time. And also I've got my little 99p sound card because the Pi also doesn't support sound out through the HDMI socket. So all of this is running from this single official Raspberry Pi adapter, and it works fine. I played around with it yesterday and I had this configuration. I can also plug in a controller. I'm not sure if that's too much power for it, but the SSD doesn't seem to take too much more power. So let's see how we get on. Okay, so now I've got that adapter plugged in, you should see that we've got internet now. It usually comes up with a notice about sharing your network. And there's the sound, which you probably just about heard on my mic. It's weird because it did say it had sound before, but it said Raspberry Pi 3. So yeah, the Raspberry Pi 3 audio didn't work for me, although it might work if I unplug it. I'm not going to do that now. I've found that if you unplug and plug in USB accessories, because it's close to the amount of power it should be using, it can reboot your Pi, so it's best not to unplug and plug things in while it's actually running. But of course, now I've got internet, I can get everything off the internet. Now, I haven't started the internet on this. This is a whole newly installed system for this video, but let's see what happens. Let's go to Amazon, because I tried this the other day, and you can play music tracks directly through. And digital music, let's type in new music. There we go, top of the pops. Let's click on that. And let's pick a track. And hopefully it will play. There you go, so pause that. It's certainly not as snappy as Linux, and I would imagine this is probably maxing out the RAM. Okay, so I hope this helps. Remember, this is in very early stages at the moment, so expect not everything to work perfectly, but it's certainly coming along nicely, and the addition of an SSD makes a huge difference. If you check my video from yesterday, it goes a bit more into using it with an SSD. But I hope you like this. Thanks very much for watching. Please like and subscribe.